All right, let's get going. You all made the right choice. Glad you're here. I mean, it's either this or Hollywood Video, so you got to make a choice either way, right? Okay, cool. So we are going to talk about a lot of things in a short amount of time. So I've prepared a lot more content than I have available to talk about in a deck, which is this, and made it available to you immediately after this. So right after this, go ahead and download it. And some of the slides I'm going to just kind of bust through pretty quickly and just kind of leave it there as a reference. And some of them I'm going to focus on kind of spending some actual time on. So I want to give you more information than less, so I'm going to focus on giving you more information, and then as we kind of move through some of these, some I'll just kind of hit very quickly and some I won't. So a little bit of an introduction on me. My name is Nathan Lasnoski. I'm the CTO for Concurrency. I've been in Milwaukee for 24 years. I started consulting 21 years ago. I'm the CTO for Concurrency. It's about a 160-person consulting company. We probably work with a lot of you already. I know a fair number of you in this audience. I've been largely working with enterprises for the majority of my consulting career, usually around the kind of like 5,000 user kind of organizations, but these same concepts apply across the stack. Do a lot of work in the Microsoft space. I'm a 13-time Microsoft MVP. So what that means is I just get really involved in the community, doing things over the last 13 years, and that's been a huge blessing to me. I am a father of 8. That's my wonderful family up there. My daughter is here for the first time. She's actually not in the room. She thought someone else's presentation was much cooler than mine. So yeah, I'm a father of 8. I'm also a triathlete, so I do Ironman 140s. And there's been something really interesting that I've learned from being in tech for as long as I have and being a triathlete, is that there's always someone smarter than you and there's always someone faster than you. So and that person who's faster than me has now become my daughter, which is a point of pride or embarrassment depending upon the day. But I think what's really interesting about that to me is that this is just an opportunity for me to share the little bit that I know from coming about this in consulting, some things that I've learned, some things that maybe I haven't learned, and for you to take advantage of that. But I'm sure all of you know tons of things that I don't know. So it's just simply an opportunity for me to share a little bit about what I've come across, and hopefully for that to be a benefit to you, and kind of hopefully vice versa, and we get to know each other a little bit more. So I'm going to spend this hour talking about 5 architectures that if I had known about these architectures or had learned about them earlier, or I wish other business had learned about them earlier, they'd be in a position to be able to mitigate a lot of the ransomware and other issues that they run into in their organizations. It's things that I have this sort of like, oh, what if they had just done this? I think all of us have had those experiences, hindsight being 20/20. So my goal is simply to share some of those with you. I've tried my best to make them very topology oriented. So every one of these, I focused on giving you a diagram and accompanying some of that with text. So leverage that diagram as you try to go to work and attacking some of these. And I've started from like most likely bad things to happen to a little bit more aspirational bad things to happen. How's that? So right at the front here, I'm going to try to talk about what's the most likely thing that you should be trying to protect yourselves against and how do you do it. And then at the tail end is going to be more like, hey, there's some things that are kind of coming down the field that are interesting to us but may not happen tomorrow but are still interesting for us to be considering. Sound good? All right, cool. So first conversation we'll dig into here, and I'll spend about 10 to 15 minutes on each one, is modern end-user computing. And I think this is probably the most interesting thing for us to be talking about, because I was explaining this to my daughter earlier today, and I said something to the fact, she's like, why are so many things being hacked? Why, Dad, why do so many things get compromised? So, we train puppies as a family. Interesting, right? My daughters have trained 25 puppies in the last year. They train them for 2 weeks, and then they return them to their owner. And I said, Maddie, what would happen if you took 4 puppies and you put them into one crate? Well, we do this at dinner time because we need a break, and we put them in this crate. It's a big crate. And she's like, well, they wrestle and they tussle and they fight with each other, blah, 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 blah. And I said, well, what if you put little things they had to jump over in that crate? and you let them kind of you try to kind of prevent them from getting in each other's faces. She's like, oh, they just jump over them. They just get around. Well, it's like, that's kind of what cybersecurity's been like for the last 21 years of my life. We kind of put everything in one crate, and we make these little barriers around the crate, hoping it's going to keep things from interacting with each other, and we just ultimately fail because our architectural model's wrong. Our architectural model for keeping puppies from interacting with each other is probably put them in 4 separate crates, right? It's just sort of logical, but that's not how we work when we design enterprise networks. Our enterprise networks tend to look like one gigantic crate with maybe a couple little hoops that things jump over. So when I think about the 2 most significant bad things to happen to you, a lot of us like to think about AI is going to take over the world, and I'm sure Elon Musk has got a lot to worry about. But what the most significant things that I see happen in organizations is just pretty simple stuff: ransomware and targeted attacks. Ransomware being the majority of things that people get compromised by. And when I have a customer that comes to us, and this has been either thousands of computers compromised, a couple hundred computers compromised, the entire OT network compromised, it's usually because some guy's laptop got taken advantage of, and it moved from person to person to person to person, and then it compromised something more important, and then that moved to something more important, and then they compromised the Active Directory, and bam, they're done, right? The same kind of story that a lot of the guys around here that are a lot smarter than me will show you how to do in real life. What I care about is how can I architect out these problems? And that's kind of what we're going to get into. So that idea of lateral movement, right? All of you guys are security professionals. You're very aware of that this is the problem that we deal with. The interesting thing that I've run into, and I've probably been in every enterprise organization in Milwaukee, is pretty much nobody's got that locked down. This situation that if I do compromise something on your corporate network, the ability for me to sit there for a long time and you not know it and move around that network is pretty bad. And most of the time when I talk to CISOs, it's like, yeah, we had our yearly, red team pen test, or we had this pen test that got done, and we did really better than last time. It took us only 2 days to get compromised as opposed to 24 hours. I'm like, okay, that tells me a little bit about you and about how you relate to everybody else. So everybody here has probably heard the word zero trust, right? Okay, this has totally become a little bit of a buzzword in a sense. And I think part of the reason why it's become a buzzword is because these are good things, so everybody gets on board with it, but few people have actually taken it to become more of an architectural model. The idea of assuming breach, the idea of verifying, and the idea of least privileged access makes total sense. But I think what's really going on here is they try to apply this to an existing architectural model and just try to put more little jumps in front of the puppies to keep them from talking to each other, rather than trying to implement something which is architecturally more sound and brings us to a better space. So I think this is a little bit of a better diagram. Now, I want to proxy something for a second. I work primarily with customers that are implementing Microsoft technologies. That doesn't mean this is irrelevant to someone who's completely in a non-Microsoft shop. There's equivalent technologies to allow these same scenarios. So you'll notice I have something like Azure AD on there. Okay, cool. We'll talk about Azure AD. But let's say you're using Google's platform. Okay, cool. We can talk about that too. Let's just think about this in the context that it could be any one of these technologies. Okay, so I'm going to sit on this slide for a minute. Hopefully you can see it in the back, because I think this is the most important slide I'd like you to leave the meeting, this whole conversation with. So one of the things that is probably the most critical activity is to come up with a way to prevent our crown jewels from being compromised. Now, there's 2 states that those crown jewels could be in. They could be legacy workloads. Think Windows domain joined virtual machines. Think your OT network. Think the kind of traditional workloads that are running on your IBMs and iSeries and things like that. And then there's the modern workloads that you have people building from the ground up. Kubernetes, SaaS-based platforms, situations where platforms are running on app services, things like that. So if we go to this sort of ransomware scenario, the things that we're mostly being taken advantage of right now, the things that are just the most obvious problems we need to deal with, it's what can we do to make ourselves in a better position? Well, the best thing that we can do is get the laptops, devices off the CorpNet. People say, hey, IT would be great if not for the users. Well, security would be great without the users too, right? When we have our workstations living on the CorpNet, what happens? One gets compromised, it moves to another, it moves to another, it moves to the server environment, and moves off. The organizations that have been really succeeding at protecting the crown jewels, protecting the server environment, have been taking the end-user computing devices and moving them off the CorpNet to their own environment that is, you could call it a guest network, you can call it a home network, you can call it whatever. But this idea that safety is coming out of me VPNing into something or being on the corporate network, it didn't work 20 years ago, and it certainly doesn't work now. So how do you go about doing that? Well, let's say you're starting an organization that has no legacy environment. Now, that isn't probably 0 of you. That happens to be us, but it's probably 0 of you. What you can do now is you can take an end-user computing device. That end-user computing device does not join ever to a Windows domain joined Active Directory. That sits off a CorpNet. Not on any, it's on a guest network, or just call it anything. Isolate that device from every single one of its friends. Your network, by default, doesn't allow anything else to talk except to the internet. That device becomes Azure AD only joined, or some other identity, but it's Azure AD only joined. This is not Windows Active Directory joined, meaning it's not hybrid joined, it's not legacy Windows joined, it's only Azure AD joined, only to the cloud. That then is managed by some kind of cloud-based management tool. Of course, Chromebooks operate that way today, right? We already know that for school networks, but that's running on some kind of cloud-based management tool. That allows us to focus on SaaS applications, Office 365 or Google, cloud print scenarios. In this case, we're talking about an organization that has 0 on-premise dependencies. All my collaborations in the cloud, all my communication, my apps are in the cloud. That happens to be my organization today. We have 160-some people. We have no on-premise network. It's all cloud-based capabilities in the blah, 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 right? There's no file servers. It's all gone. Now, what the hell do you do with the regular old company that has all the rest of the stuff, right? That's really the big problem, right? Like, yeah, easy for you to say, talk about every enterprise that doesn't have that going on. Okay. Now, what you can do is have your workstations not Windows hybrid joined, not joined to the Windows Active Directory domain, that's really what it means, and facilitate authentication through Azure AD or through another authentication mechanism to your on-premise targets. Game 1 is, can I eliminate my file servers? Because that's the biggest boat anchor that's tying you down. The second thing is, can I facilitate access to legacy applications in a way that doesn't require me to access that application via a VPN? Can I silo it off and facilitate conditional access only to that application? Basically, my goal is facilitate some level of proxy that allows me to access legacy applications and legacy file server content via some kind of published vehicle, whether that's Citrix or an AVD published laptop or a proxy vehicle. There's a lot of different kind of hybrid VPNs that exist that can take a modern end user device, never physically on the CorpNet, and allow it via some kind of internet vehicle to be able to access these published endpoints. And the benefit of this, and I can't stress it enough, the benefit of this is that when this device is compromised, it creates a substantially more difficult way for it to be able to compromise servers and applications that sit on your CorpNet, because traversing from that point requires a lot more checks. A, it's not on the CorpNet to begin with. B, it requires conditional access in order to move from point A to point B. So this is a fundamentally different structure that is predominantly focused on creating a sort of internet out, internet down approach to accessing these applications, and moves away from this idea that things just kind of are all on a CorpNet and are, because they're contiguous, that allows them to talk. Trying to move away from the contiguousness is really where the modern communications environments are moving, and especially provides us the ability to insert different protections around this structure. So this is something that is sort of obvious when you're accessing Office 365 or SaaS-based applications, because it's just how it works today. It's not obvious to us because we're still kind of hanging on to some of these file server legacy environments that require that contiguousness. But if you make a hard line, and I'm working with organizations that have 20, 30, 40, 50,000 users that are going straight to this model right now or already on it, what this means is that when one of their endpoints is compromised, their ability to isolate that endpoint from someone else is substantially increased over the ability for them to isolate it when it's sitting on a CorpNet and communicating. So that's sort of architecture one. Now, the components of that make that possible are some kind of conditional access, and there's a number of technologies that facilitate that. Conditional access being like required thing one on, do I know what the device is? Is it managed? Is it healthy? Is the user who they say they are? Is the user healthy? All those elements go into whether or not I can facilitate and move through that chain. So I'm providing all these chances for me to have a kill chain from point A to point B through to that managed network. Second is that that's a modern desktop. It's cloud joined. It's in the context of being cloud joined, it's then facilitated to access different properties based upon that cloud joined authentication and authorization. And then as we get to the data center conversation, there's micro-segmentation happening on the back side of this story as well, which is more the sort of data center conversation that we'll talk about next. So this is sort of a comparison between classic desktop configurations and what you would call a modern desktop configuration. Classic being this idea of has to be contiguously on the network. It's this sort of SCCM configuration manager managed. Name your other on-premise management tool ecosystem. It's this sort of high-touch ecosystem. Our goal with the modern desktop is essentially to create replaceable endpoints that have nothing valuable to them except the fact that I authenticated to it. And if something's down, it's broken, I threw it out, somebody stole it, I get a new one, I give it to them, they access all their stuff again. And for the things that we're already accessing through G Suite or Office 365 or whatever have you, that's pretty obvious we already do it today. What we're trying to do is take that same model of replaceability and bring it to how we access those legacy apps instead of placing these devices on the CorpNet and making them their own little special snowflakes. Also want to show you this. If you haven't kind of read Microsoft's direction on sort of moving to cloud managed, this is sort of complementing the architecture I just mentioned. There's a similar story for some of the other cloud identity providers. Sort of state one is you're attached. That's pretty much everybody who has M365 right now. If you're doing hybrid join, many of you probably are. That simply means that you are Windows Active Directory joined and Azure Active Directory joined at the same time. There is no supported way to move from a hybrid join device to an Azure AD only join device, except using some really complicated transposing with ProfWiz. Totally sucks. We figured out how to do it, but it's not great. So the best journey to sort of the cloud only attach is new devices. You're rolling out new devices, Azure AD only joined, it works. And you kind of figure out that like 75% of your users could do this tomorrow, and there's like 25% where it's a really big pain in the butt. So that process ends up being part of the journey. Ultimately, then you're trying to get to this point where you're minimizing the Windows Active Directory domain controllers because they represent really your biggest compromise point. I mean, if there was one thing that we're trying to prevent, why do people want to be on my CorpNet? A, it's where much of my data is, but B, it's where my identity is. And if I can get behind the identity, of course, that's what a lot of people, other of these guys will talk about, is I'm able to compromise quite a bit. So that's what we're trying to avoid. So there's a great site in this, aka.msad2 Azure AD. Great story. Similar story with other identity providers. Of course, moving to passwordless auth. Many of you have already started to get to this point. It's interesting. I think one of the things I've most been impressed by is the sort of move to even like number matching in the context of passwordless auth on multi-factor. I don't know if you realize what percentage of people will approve a multi-factor auth prompt on their phone without ever looking at where it came from, but it's ridiculously high. And if you consider how much of your personal apps people will do that for, it's gotten to a pretty bad state. So even with that, the advancement of passwordless auth is pretty important to the same story. Because then once you move away from the idea of of contiguous corporate joined devices to more of cloud joined devices, what you end up dealing with more and more is just how important conditional access and identity really is to the rest of the story in gaining skills here. Okay, so identity governance, something you can check out later. Same with some tips in moving to modern state. And then this is some of the blockers we've seen. I want to hit this really quickly. Ironically, the things that kind of keep us from moving to this are traditional file servers are probably the most significant thing, because some companies, they haven't moved to cloud-based collaboration yet, which is like, holy cow, you haven't done that yet, but like a lot of them have these just like really traditional file servers. You find out that like that ends up being the biggest blocker. But because most companies have kind of moved to modern collaboration, the file servers end up being kind of like these like boat anchors for more traditional things, you can kind of make that a like side thing that only a subset of the users really have to deal with. Like if you give a new sales rep a device without having access to the file servers, a lot of times you can get away with that, whereas maybe sometimes the engineers, they might need that. So you can start to take like parcels of your organization and get them cloud only. Okay, next architecture is cloud data center architecture. You could take this same concept into on-premise data center architecture if you really wanted to, understanding that same security concepts apply. What I'm really contrasting this against is like legacy data center architectures. So when I think legacy data center architecture, I think everything's on a VMware cluster, every server can talk to every server for the most part, and we have no idea what should talk to what. It's really kind of the key problem. And ask yourself the question of, why have so few organizations truly microsegmented their data centers? It's because it's hard. It's difficult, right? I have to have all these application owners know what talks to what. Well, what I've found is that when companies move to the cloud, I have to figure that out anyway. So when I'm doing a cloud migration or a company is starting to load new workloads in the cloud, that is the #1 time to say, stop. This is a point where we can decide and understand what should talk to what and establish a cloud architecture that establishes isolation within our organization rather than allowing everything to talk to everything. So a lot of these companies, it's like it's really too bad. Like I was talking to a company the other day. They spend about $3.5 million a month on Azure, and they had loaded everything into just a big contiguous cloud environment with a couple big subscriptions. Everything could talk to everything. They had no network security groups, nothing built out. It's like, holy cow, man! Like you missed your shot. Like you had to talk to every part of your organization to do this move, and you just missed it. And now good luck going back and talking to those parts of the business to try to make a new change that's a breaking change in their environment. It's tough. So when I look at companies migrating, there's really these 3 states. The Horizon 1 state, which is what you'd call that legacy data center operation state. Everything talks to everything. This Horizon 2 state is, we have virtual machines, whether they're migrated to the cloud or like some on-premise sort of cloud equivalent, that are in a modern operational state, meaning infrastructure as code is how we did the deployment, meaning they have microsegmentation applied, meaning I'm using modern tools to back up and control them. And then we have Horizon 3, which is cloud native applications that are operating within a cloud environment, right? So this is like containers or microservices or an app service. Both of these Horizon 2 and Horizon 3 states are tremendous opportunities for us to change the game on the back end of Zero Trust. Like that front end of Zero Trust is like, all right, I want to make this real. I don't want these devices on my CorpNet. In fact, they're not going to talk to anything except themselves and their target. They're going to pretend like they're actually on the internet. And then we have the data center side where like, I want to move away from everything being contiguous. And for the virtual machine situation, it kind of looks like this. There's an equivalent architecture of this in AWS, Google, OCI, Azure, same kind of idea. There's an isolation. Each one of these represents a application. Each application maintains some level of network security group or some kind of virtual firewalls. Inside of each of these live your resources, becomes a verticalized network structure that says this can talk to this, but it cannot talk to this. Just having that by itself represents additional controls that exist within our data center. Now, if someone gets into it, they can still move around. They can't move around quite as easily as they did before. Yeah, I'm kind of putting up the blocks between the puppies, but at least those blocks are there, and I put other things in other boxes. So the idea behind microsegmentation is truly to say, my application should only talk to what my application should talk to. And this is one of the hardest things we have to do in network security. Now, there's some capabilities. Vendors are producing this sort of automated microsegmentation tools, and it's getting better. We're getting to a position where we can start to lay that out. But the number of companies that have this versus the number of companies that have nothing is 20 to 1. And I can say that from being in hundreds of companies and seeing the same problem. It's a state that's really sorry. And when we're moving to a new architecture, this is a tremendous opportunity to make it better. Like if every one of you guys went back and said, whether it's in our on-premise data center or in a Azure, Google, AWS, name your cloud, we implemented microsegmentation, you're getting a tremendous win. Now, you're gonna have to break some things to be able to make it better, but this is the time that you have the chance to do it. The other thing I would call out is that when people are building out their cloud environments, the biggest mistake I see is they under-segment the subscription structure. So this is an example of an Azure CAF landing zone. There's a AWS similar state to this, looks pretty much exactly the same. And what you'll notice is that all these subscriptions are broken out into their own subscriptions, and the landing zones scale vertically. This is sort of exponential. Hundreds of subscriptions might exist in landing zones. And many of the organizations that have done early moves and moved thousands of machines, they've had, let's say, 5, 10, 15 subscriptions at max, and they haven't done enough isolation within the environment to truly put themselves in a position to, A, mitigate human mistakes, but B, also put them in a position where they can mitigate security mitigate security disasters from somebody moving around. What you notice is that even on the platform side, things like identity, management, and connectivity get isolated. A, because they have different owners. B, because they simply should. Each of these elements are then deployed via infrastructure as code. Why? Because this is the most frequent things people screw up. When we get called into people's Azure environments to help fix them, the number one thing we find in here is that someone just messed it up and they don't know what the good configuration was. They messed up their express route. They messed up their network configuration. They don't know why their Active Directory can't talk to their subscriptions anymore. All these things that people just cause a major disaster on, it's just because they don't know. So recoverability is as important as security here. In fact, it is security to a degree. So when you look at scale structures, over-accentuate the breakout of the sort of boxes that things go in, and you'll find that even though it adds a little bit of management overhead, it really doesn't if you move toward an infrastructure as code-based deployment approach to how you understand and manage your entire cloud environment. And you get to operating things as like, you ever hear the idea of like cows versus pets? You probably all heard that idea, Jeffrey Snover. That's sort of the idea here, right? I'd rather have more subscriptions run as cows than I'd rather have less subscriptions run as pets. And I can put myself in a position where I can truly scale out the environment. Okay, so microsegmentation, hit that. This is totally something you can check out later, but what I did is provided a little bit of a breakdown of common security function responsibilities in a cloud ecosystem. Some of you may be living in like true the security roles. Some of you may be like in network engineering or cloud engineering or whatever. I broke this out so you can kind of see like across the different functions of the security in the cloud, how does that start to change as you move from cloud adoption to Horizon 2 to Horizon 3, and people take on different responsibilities. So kind of check that one out a little later. So these are sort of my non-negotiables as you think about moving to a modern state. Microsegmentation, infrastructure as code, cloud backup, cloud patching. Hit those 4 things, especially the first 2. If you missed the first 2, don't come crying to me. Those are the things that everyone should do right at the start of their project. And if you do that, everybody's skills get uplifted. I think the biggest reason people don't do this is because management is afraid people can't learn it. And I think that's really sad. It's really sad. Like, people can learn this stuff. Get out of your box, learn to use microsegmentation, learn to use infrastructure as code, and this will be easy. If you keep thinking about click, next, deploy virtual machines, and it's just kind of too bad for you. Like, this is an opportunity for us to modernize our skill sets. Things to avoid: don't shift without microsegmentation. Not taking the time to implement infrastructure as code is just kind of a tragic situation. And then these are not security, but cost management and doing test recoveries are pretty critical too. Actually, recovery really is a security thing. So critical things for moving to that modern state. You can hit these lack of knowledge things later. Okay, next topic. Next topic, data mesh. Who's heard of data mesh before? Okay, cool, few of us. Okay, so what is a data mesh? A data mesh is the assumption that data exists everywhere in your environment. And in order for us to apply consistent security and architectural controls to it, we need to make that assumption. Just like we make the assumption on assumed breach, we're making an assumption that data exists everywhere, and we need to establish a domain-driven structure that facilitates that autonomy to exist in the environment, but for governance to exist across the environment as well. Data mesh can scale from 0 to 100 different organizations and domain-driven topologies. Its main focus is simply around allowing us to function at scale. So it facilitates the design concept, and its goal is to allow us to exist at scale, or just simply to understand that there are different aspects of that topology that we need to understand and have owners for. So here's a little bit of a build out. Now you will not be able to see these words because they gave me a little screen, but that's okay. So it says things like executive financial visibility, delivery visibility, like where's my truck, personnel optimization content, demand inventory optimization, manufacturing optimization, like think OT data. Think quality optimization, like video content. You went to some of the keynote, they had that video content. Well, like, imagine you have a video stream coming from your OT environment that's about quality, right? You have sales optimization content. Think your CRM system. Digital optimization. Think stuff coming from your website platform. Behind each of these exists a functional data domain, financial data domain, customer service data domain, employee sat data domain. These are ways to articulate the context of data that exists across the environment. That data then is backed up by an owner. The owner is a person who is accountable for understanding the data exists in the domain. One of the biggest mistakes companies make when they're moving to cloud data estates is they just throw everything in a big data lake and hope for the best. And they get themselves to a position where it's a complete security nightmare and they can't operate at scale. Data domains are about providing the necessary isolation within the cloud data environment and then building out cloud products or on-premise products that fulfill the domain's goals. Also maybe applying standard products across the entire stack or allowing diversity of products based upon the goals of the domain. Underneath that domain exist consumers. Consumers are people like business consumers, data scientists that have different goals. A model built for a business consumer is going to look a lot like an abstraction of data that runs in a report, whereas a data that a data scientist might use would be something like raw data that exists maybe at stage 2 of the data extraction process. So there's different needs that exist within a particular domain. And then across that has to exist something called a certified data set, policy, visibility, lineage, and governance. And there's a wide diversity of tools that can do that. Things like Informatica or Purview or name your tool, right? There's a whole variety of tools. The goal is that you have something that can be the kind of master of puppets across the environment, not to prevent more data from coming in, but simply to know it exists and to be able to map it back to its owners. So inside the context of that, you have data products, and those data products can be standard data products. This kind of normalization is things that are used everywhere. Imagine you're a Power BI or a Tableau environment. You're kind of standardizing on something you use for visualization. Generally accepted across the domains. They're trying to skill up on a thing. However, there's also domain-specific products. This is very much like, think like data scientists right now. Like there's a whole diversity of tools that data scientists are using. If I try to like draw a line and say, well, you will not use TensorFlow, but you will use Azure Machine Learning, or you'll use this, or use this, like whatever, like it's advancing so quickly, you don't even have the rules to be able to write that yet. So domain-specific products are gonna totally align. Like if I'm talking about an OT environment, I will probably be using Rockwell or Ignition or something that's really centric to that. So you're going to make some choices around what kinds of products are going to line across those domains. You're also going to make some choices about what the level of security and data control is as you move in different implementation options. So, many less mature scenarios will basically take data, throw it into a raw data lake, do some kind of transformation on it, and throw it in front of a consumer. The problem with that is you start to miss some of those intermediary needs, the machine learning needs, some of the security needs, some of the de-identification needs that exist in some environments. So that's where you start to get to some of this like silver, gold, platinum sort of levels inside the context of your data estate. And as you get into some of these higher level, ultimately duplicating data sort of topologies, you're getting to a position where some of the data estate needs to have that to exist for simply compliance reasons. So we will not go into this in detail, but this is kind of an example of how those data lake flows start to exist in an environment. And then simply just the idea, and we hit this earlier, the idea of a dual path structure, that your data domains are going to be isolated based upon functional area. Your governance of that from a security perspective needs to understand who are the owners, who are the people who need to access that data at different levels. So think about it this way. In this top level structure, there's a report layer, there's a data mart layer, there's a data vault layer, there may be an ETL, and even a raw data lake. Who can access what in that structure, and how do I control it? That's the whole point of building out domain-specific controls and security inside the context of a data mesh. So that domain has rules, and you're indicating who and how do they have the right to access data. And where is it simply like moving for the purpose of me containing it and handing it versus allowing people to access the data. And that's where governance tools come into play. So establishing a governance layer is about A, knowing it exists, because we can't govern it if we don't know it exists. Establishing a security policy framework associated with data domains, and then establishing enablement functions for those data domains, enabling people to be able to use it. And a lot of that might be the data organization's responsibility, but let's face it, this is a security responsibility as well. What data certain people have access to versus other people have access to is one of the most critical things that we think about. Why do people want access to our corporate network? So they can get our data. And this is an opportunity for us to control it. I'm working with an organization right now. They're feeding every second of their OT data into a cloud environment so they can do all sorts of different types of reporting on it. Don't you think a hacker would like to have access to that? Absolutely they would. Like, this is an opportunity for us to be able to govern it and make sure it's done well. So applying lineage to it is absolutely critical, knowing where it came from and where it went, and then applying curation to labeling and authentication requirements, different types of data that just simply shouldn't move from one layer to another, the de-identification of information for certain types of reporting roles, all super critical. And then ultimately kind of building these meta models. And I know you can't see this, it's just a super small, but the idea of a meta model is simply to say, I have an ability to classify data as it moves from different stages that lets me more flexibly apply security rights and access to that data. So think about that in the context of things like classification, public, confidential, sensitive data, restricted data. All that needs to be applied in addition to just basic rights that go against those verticalized towers. All right, any more questions on that? We'll hit it later. I have a detailed slide on how that looks, and we will not get into that. The summary of this is avoid throwing all your data in one contiguous lake. If your company is doing that now, they're making a mistake. It's not a good practice. It's not the established forward practice. It's kind of like the one contiguous lake story is kind of like the one contiguous subscription story for virtual machines. It was what everybody thought they should do, and a lot of people did it, but it ended up being a really bad idea. So this is really about avoiding that problem. Establishing clear ownership associated with each domain, a person who knows where that data came from and why it's important, and a clear pattern of access that's understood and you know who's accessing it. I can guarantee you this is not the state in most enterprises because I've seen a lot of it, and this is an opportunity for us to really build this out in a way that's understood by the organization from a security perspective. Okay, next topic. I told you you're going to get a lot of stuff here. Next topic, microservices. Well, we're going to get done. We got 20 minutes yet. Okay, microservices. So, we started off with like, I've got end-user computing devices I'm trying to isolate from everything, right? Like the most obvious thing we need to do in information security. Move then into the state of servers, and all servers can talk to each other. We want those microsegments. Okay, cool. Now we're getting better. And then we get to data. That's sort of the next thing that people are going to try to access. Well, now we're taking a journey into what is the modern architectures that people are building their applications toward. I was working with an organization the other day, and they're moving from a huge monolithic application to a microservices-based application. Awesome. That's great. You should do that. However, this is a big journey for them skills-wise, right? Because the monolithic application is running on Windows web servers, and this is a bunch of big Windows SQL Server backend. This whole kind of very centralized structure of how they built out this application. Microservices have very little in common with that. Well, in a sense, because it's really breaking it out in a much more significant domain. So this is your traditional monolithic architecture. I remember going to see Scott Guthrie, when he came to .NET Talks in Milwaukee 15 years ago, talk about building things on .NET based on this exact architecture. And that was a pretty cool story at the time. But now, really, we're starting to move into something more akin to this, which is really the idea that in a microservice, you start to isolate the function to the database. The function to the database is really the main alignment. This is probably a better shot at that, which is the idea that function to database, function to database, function to database, and then putting things like API gateways in front of the context of the services, serving from a client, and then this service talks to another service to actually get what it gets done. In the context of orchestration, that's where you have things like Kubernetes, right? Which is think of each one of these as a container, okay? So each one of these services, got a service, each one of these services runs in a container. That container can be operating in any number of particular places, on-premise, a cloud, on-premise cloud, general cloud, a tier 2 cloud, wherever, it doesn't really matter. And that functional area has the opportunity to scale out. The reason I bring this architecture up is because most security teams just haven't even gotten into this yet. I'm working with a company right now, they got about 30,000 users, they got about 200,000 something customers. All these virtual machines moving into a cloud environment. But then the most important application of the entire organization is this new web app they're building. It's based on containers. It's used for every order in this organization. And the security team has no idea how it works. It's tragic, but it's funny because it's true. So it's just part of this idea that this is where we have to keep growing our skills to be relevant to the application development teams that are doing really interesting and cool things to scale their businesses. So ultimately, a microservices architecture then breaks out even further, right? And you can play with this later, but the idea that you start to factor all these things together. One of the things that becomes a danger zone of crossing the streams in Ghostbusters, but people are doing it because it kind of is the only way to do it, is this idea that, think of this as the modern architecture. Here is the interaction with the legacy system. So we have this old as dirt legacy system that we're interacting with. It could be an iSeries, it could be the old .NET application that we haven't upgraded. And there's this thing called an anti-corruption layer, which is basically a way with another microservice in front of it, which is sort of a way for me to take my modern stuff and talk to the old thing. And this is where a lot of funny business starts to happen because you have to make things work with the legacy application. So I think one of the things I'm really trying to get across here without having an entire class on microservices is this is a really good opportunity for you to index all the applications that are important to your business, know which ones are being built that are brand new, and use that as an opportunity to insert a person from the security organization with the right roles into that part of the picture to understand what's going on and be relevant in the context of that architecture. Because most organizations, they just simply aren't. They have identity people, they have legacy Windows virtual machine people, but people that truly understand this part of the picture are they're just kind of leaving it up to the app dev team or the product team. They're not really sure how to build them. The other thing that is a real issue here is just the idea of container orchestration. So when people are building these container-based applications, I was talking to one that was doing a big IoT-based platform for vehicle, remote vehicle stuff. And they had deployed it into Azure Kubernetes services, which, cool, great. But the problem is people understand Azure Kubernetes services even less than they understand containers. So the infrastructure team doesn't understand it, and neither does the application team. It just kind of exists, and it's running something. But there's all sorts of ways to misconfigure AKS in a similar way to you can on GCP and AWS. So this is a real opportunity for us to understand and build the right security layers around how we're maintaining the container orchestration element and also patching and updating the containers themselves as they exist in production. So one recommendation I would give there is, they're becoming Kubernetes or container hosting solutions that do not require you to maintain the Kubernetes environment. Like AKS, for example, you have to maintain that Kubernetes environment. Things like Azure Container Apps or GCP's option, like they kind of like abstract that away, which has a lot of advantages just from a hosting maintenance standpoint. So kind of think about where those could come into play in your build out, because then you can kind of get to a point where you have to care less about this. But the only problem when people go down that route is they really don't understand it at all. They're just deploying a container in somewhere. So at the net of this is understand microservices in respect to the new applications being built, and understand the container hosting option and how you apply security to it. Furthermore, understand the recoverability of the container environment specific to Kubernetes specifically if you're using Azure Kubernetes Services or any other container hosting option, because recovering that is it's almost second bad to like I screwed up my identity or express route. It's like I have no idea how to get my container environment back up and running. The whole idea behind containers is redeployability at ease, but that's not necessarily what we're running into here. Okay. So I'll let you jump past that. Lots of detailed diagrams. Ultimately, a number of security notes. It'd probably take the next 10 minutes to walk through each of these, but I think each of these are probably worth you taking a look at. So these are some summary container notes associated with making that better for yourselves. All right, last one, and then I get an extra. IT, OT. Who knows much about OT in this room? Yeah, you're like the man. There's some really good talks in a couple of succeeding talks here on OT. I totally recommend going to that, because that for me, like over the last year, that turned from a black hole into something I actually started to understand, like just barely. Because OT is like the graveyard of Windows XP. You walk around these factories and you just basically have these air-gapped Windows XP or like other legacy PLC platforms that are running the most important hardware in the entire environment, running like vats of molten metal and stamping machines and this and that. And you realize how vulnerable we really are if someone actually connected to these things. So it's just really scary. And that kind of modernizes itself to the IoT world in like the connected garage door openers and the connected boats and the connected trucks and all these things. But the same problem kind of exists there. It's just a bigger problem because there's more of them. And it's people are driving them there, or they're making their toast, or it could close on their kids from the garage door opener. It's got all these other problems associated with it. So if you think about OT, it's generally userless in a sense that like nobody really interacts with the actual platform itself except when it's updated every once in a while. And it's usually on like really legacy architecture infrastructure. And it's limited in what it can do, but it's very high value. It's really at the end of the day. It's super high value stuff, and it's exposed to people that walk around in the environment and they have access to these things all the time. Yes, 5 minutes, awesome. Okay, so compromise angles. The most obvious compromise angle is someone has a device, and this happened to an organization that we helped fix, they acquired this business got nuked because contractor came in with a laptop that had been compromised. They plugged it into the air-gapped system to update it. Bam, right? Because now that air-gapped system can be controlled via the compromised device. So OT environments are just tremendously vulnerable, but we just keep them in locked rooms, and we hope nobody goes in them. But because we can bring along riders into the locked rooms, people can really compromise them easily. These are the passwords and the usernames used by most of the compromised OT devices. Note, everything's admin or root, easily compromised environments. Lots of good studies done on that. I highly recommend the STRIDE model for IoT security, which is simply an opportunity for you to understand you have a user zone, you have a device with a field gateway, and then a relationship to what is your cloud gateway. I think the most important thing about IoT is understanding that like we have an opportunity to be able to modernize this environment and apply security to it as they are trying to get data from these environments. Like 5 or 6 of the projects I'm doing right now are just getting data out of the OT environment and applying AI to it. Well, they want to do all these modern things, but the most difficult part is just getting the data out of the OT environment safely. And a lot of these environments you can clean up by actually fixing the way they're getting data out of it today, which are very vulnerability risked. Some interesting elements associated with OT security. Each of these I think are really important. I provided a link to some of that data. And then kind of a general word about OT environments, which is much of the data in the environment that you're caring about is from OT. The one-way feed solution can work, but it's still dependent on like you applying some sort of hardware-based solution. Ultimately, the best way to address these problems is applying some commodity capabilities from things like Ignition, Wonderware, Rockwell, Microsoft. They all have kind of Industry 4.0 capabilities to modernize the OT environment as you look at the topology. Okay, I had a thing in here about AI. Really, the main thing I wanted to say about AI before we move on to like just closing this guy down is, and I only bring this up because we're starting to do a lot of AI projects, is that as you are doing OpenAI projects, you essentially provision a copy of the OpenAI instance in your Azure environment or in your, if you're using another kind of open source platform, right? If you're using, specifically using OpenAI, you're provisioning a copy of that in your Azure environment. And that becomes a model that then is augmented by tuning or embedding or other kinds of injection via things like Azure Cognitive Search. And that becomes a major attack pattern that people can take advantage of. So that's, you could start this off by saying like, hey, watch out for your AI models. This is gonna be a problem you're gonna deal with. It's probably not the one you're gonna deal with tomorrow, but it'll be down the road. But it's less important than everything else we just talked about. So everything else that took from here to there is way more critical than dealing with like, did I have privacy on it? Does ChatGPT know about my this and that? Okay, so I'll leave that in the deck. Where to get the slides? Here's where you get them. So nathanlasnoski.com. You can find me on Twitter and LinkedIn. Please connect. I'd love to hang out and chat and follow up with this. Download the slides. If you have questions or you want to argue with me, let's argue about it. I'd love to have that conversation. And it's been really great spending some time with you today. I really appreciate you choosing this session. And let's talk later. Thanks.